Okay, here's another video that's talking about static equilibrium and the use of pulleys. Okay, so in this problem we have a 600-pound crate supported by various rope and pulley arrangements, and our task is going to be to use the idea of static equilibrium and free body diagrams to figure out what the tension is in the rope. Okay, so these are pretty easy problems once you see the trick. Again, nothing's obvious till it's obvious, so hopefully by the end of this video it will be obvious to you. Okay, so let's start with part A. Okay, so in part A, we're going to look at a free body diagram. All right, so here's the pulley, and what we know is that there's a weight. Okay, technically you could do a free body diagram on the 600-pound weight, but I think that we know that that's going to result in a tension force being pulling down on the middle of the pulley with a weight of W. And this is a 600-pound mass weight, and if you convert that to pound force, you know, that's the beauty of pound mass, pound force on Earth. Those are the same values. Okay, so this is 600-pound force. Okay, so pulling up, we have two tension forces, and they're going to both be the same. Okay, so what I have here for the solution to part A, based on this free body diagram, it would be 2T is equal to W, so the tension in the cable would be 300-pound force. Okay, so there we go, that's part A. All right, now let's look at part B. Okay, in part B, I have a couple of free body diagrams I'm going to need. I'm going to need to label the pulleys. So here's pulley A and here's pulley B. Okay, so what I have then is at part A, I have this system. Okay, and it's got two tension forces here, and the weight here. Okay, and then in part B, I have another pulley, and there's two tension forces here and here. And then a third force pulling up and to suspend the pulley. You know, that's the connection to the ceiling. Okay, so I can look at, you know, this, and I'm wondering what the tension and the forces would be, and it turns out I can get that straight from this free body diagram, and again it's going to be 2T is equal to 600, so T is once again 300-pound force for this pulley arrangement. Okay, all right. Well, let's move on to part C. Okay, so moving on to part C. All right, with part C, I can draw the free body diagram. Okay, and I see that I have a connection to the center of the pulley with a tension force, because it's a cable pulling, it's T, and at the one edge of the pulley there's another tension force, and the third edge yet another tension force, and then we connect that and we have to suspend the weight. All right, so I'm looking at this, and I know sum of forces equals 0 for equilibrium, and I get that 3T is equal to W, so in this case T would be 200-pound force. Okay, all right, so let me, I don't want to crop, I want to copy. Let me copy this diagram and we'll do part D. Okay, so for part D, let's take a look at the free body diagram at point A. All right, there's lots of pulleys here, but you can kind of go straight to it. I'm looking at part A. I have a force pulling up from the center of the pulley. I got 3 from the edges. I'm sorry, 2 from the edges. And then I have a weight coming back down. Now, what happens with the other pulleys, it depends on how the pulley arrangement. But at this point, I have to have static equilibrium. So this is good enough. I can tell that I would have 3T is equal to W for this pulley arrangement. So once again, T is 200 pound force. Okay, so finally, part E. All right, so part E, again, we can look at system A, but we need to be clever about it. I think what you could do, remember with free body diagrams, you can kind of define the system the way you want that to be. You could say, all right, let's take a look at this as an object. Okay, so we have this as an object. What do we know about the forces that are being pulled on that? Okay, and so I can see that I have, I'll mark these. Here's a yellow cable. I move this to yellow. All right, here's an orange cable pulling up. Here is a red cable pulling up. And finally, extend this one on up. I have the purple cable pulling up. Okay, each of these has a tension T. And then I have the only thing pulling down is the weight W. All right, so treating that as a system, what I get is 4T is equal to W, and in this case, T would be 150 pounds force. Okay, so those are examples of pulleys. I like these because you can do a free body diagram and answer questions, and there's not a lot of difficulty in solving the equations.